Space exploration, the ultimate frontier, a testament to human ingenuity and our insatiable thirst for knowledge. It represents the pinnacle of human achievement, where science, technology, and sheer determination converge to push the boundaries of what we know and what we can achieve. But as we push the boundaries of what's possible, venturing further into the cosmos, we're constantly reminded that even the smallest details can have astronomical consequences. The vastness of space leaves no room for error, and the tiniest miscalculation can lead to monumental failures. In 1999, NASA embarked on an ambitious mission to study the Martian climate and atmosphere. This mission was a part of NASA's Mars Surveyor 98 program, which aimed to better understand the red planet's weather, climate, and surface conditions. The Mars Climate Orbiter, a marvel of engineering packed with scientific instruments, was poised to unlock the secrets of our planetary neighbor. It carried instruments designed to study the distribution of water vapor, dust, and temperature in the Martian atmosphere, providing invaluable data for future missions. But as the spacecraft approached its destination, a series of seemingly insignificant errors would conspire to turn this mission of discovery into a costly lesson in the importance of precision. The journey to Mars, fraught with challenges, was about to face its most critical test. As the orbiter prepared to enter Mars's orbit, a series of course corrections were calculated and transmitted to the spacecraft. These adjustments were crucial to ensure the orbiter would enter the correct trajectory for its scientific mission. Everything seemed to be proceeding according to plan. The mission control team, confident in their calculations and the spacecraft's performance, anticipated a successful orbital insertion. But, unbeknownst to the mission control team, a subtle but critical error had crept into their calculations, an error that would have catastrophic consequences. This error, hidden in plain sight, was about to unravel the mission's success. The error, as it turned out, stemmed from a fundamental mismatch in units of measurement. A simple, yet profound oversight that would lead to a dramatic failure. While one team of engineers working on the project had used the metric system, the standard for space exploration, another team had inadvertently used imperial units. This discrepancy, though seemingly minor, set the stage for a major mishap. This seemingly trivial discrepancy, a simple case of lost in translation, would prove to be the mission's undoing. The lack of a unified measurement system led to a cascade of errors that would ultimately doom the mission. Specifically, the software responsible for calculating the orbiter's trajectory was sending thrust instructions in pound-seconds, a unit of impulse commonly used in the United States. This unit mismatch was a ticking time bomb. However, the spacecraft's onboard computer was expecting these instructions in Newton seconds, the metric equivalent. This fundamental miscommunication between software and hardware was critical. This discrepancy meant that the orbiter was receiving thrust commands that were off by a factor of 4.45. The spacecraft's trajectory was being altered in ways that mission control did not anticipate. As the orbiter approached Mars, this seemingly small error had a compounding effect. The spacecraft's path deviated more and more from the intended trajectory with each correction. Instead of entering a stable orbit, the spacecraft plunged too close to the planet's atmosphere. The thin Martian air, though much less dense than Earth's, was enough to cause significant drag on the spacecraft. The consequences were swift and irreversible. The Mars Climate Orbiter, unable to withstand the forces exerted by the atmosphere, began to disintegrate. The Mars Climate Orbiter, designed to study the red planet from a safe distance, was torn apart by atmospheric forces. Years of work and millions of dollars were lost in an instant. A $125 million mission, years of planning and preparation, reduced to a shower of debris scattered across the Martian surface. Financial and emotional toll on the team was immense. The mission, once a symbol of human ambition, became a stark reminder of the unforgiving nature of space exploration and the critical importance of communication and attention to detail. It underscored the need for rigorous checks and balances in every aspect of a mission. The loss of the Mars Climate Orbiter sent shockwaves through NASA and the scientific community. It was a wake-up call that reverberated through the halls of space agencies worldwide. It forced a re-evaluation of procedures, a renewed focus on communication and collaboration, and a sobering reminder that in the pursuit of knowledge, even the smallest oversight can have astronomical consequences. The lessons learned from this mission continue to shape the way we approach space exploration today, ensuring that such a mistake is never repeated.